Hello everyone, this presentation is about how climate change impacts our food supplies. Our group is made up of Mina Rani and who is speaking to Sergio Murcia. Let's get started. The most basic of our climate change facts is that, according to the recent IPCC study on the condition of our climate, the last decade was likely the hottest in the last 125,000 years. For around 100,000 years, we have been alternating between glacial ice age and warmed interglacial time like ours, but we have now reached temperatures similar to those before glacial periods exist. Climate change refers to a long-term shift in temperature and weather patterns. This shift may be natural, but since the 19th century, human activity has been the main drive of climate change. Climate change is accelerating in an unprecedented rate, and much of evidence apply that global temperature will continue to rise, and that human activity like fossil fuel burning, deforestation, and agriculture are the principal attributors. These activities emit greenhouse gases, such as carbon dioxide, methane, and nitrous oxide, which trap the sun heat and warm the atmosphere, in essence the term of greenhouse gases. Natural processes also emit greenhouse gases. However, the ability of trees, soil, oceans, and other things to sequester emission has typically counterbalanced these emissions. Greenhouse gases emissions are produced by food system operations such as producing food, transporting it, and storing waste food in landfills, all of which contribute to climate change. Livestock production is the most significant of these sources, accounting for 14.5% of worldwide greenhouse gases emissions from human activities. Meat from ruminant animals such as cattle and goats emits the most greenhouse gases. World leaders have agreed that the average global temperature rise should not exceed 2 degrees Celsius above pre-industrial levels in order to avoid the most catastrophic climate change scenarios. Even if this objective is achieved, many climate impacts, such as sea level rise, would most certainly persist for generations. Food waste is the single largest component of soil waste in landfills, and in incineration approximately 21% of it. When food waste decomposes in the absence of oxygen, such as in landfills, the microorganisms that break it down produce methane, a greenhouse gas with 21 times the global warming potential of carbon dioxide. The single largest share of livestock-related of greenhouse gas emissions, the 39%, is from etheric fermentation, a digestion process unique to the ruminant animal that releases methane as a byproduct. Most of the methane is released through burping, not farting. Another major source include manure (26%), which emits methane and nitrous oxides, produce food for animals (24%), and clearing the forest for food, crops, and pasture (9%).
Greenhouse gases emission by the state of supply chain. Greenhouse gases emission associated with United States food supply chains are predominantly from food production, which is 83%, with much smaller contribution from transporting food and food ingredients 11% and food retail 5%. Transporting food from stores to home refrigeration, cooking, and emission from wasted food were not included in these estimates, but are also significant contribution of emissions. So in this graph, I'm talking about the concentration of atmospheric greenhouse gases. Prior to the Industrial Revolution, atmospheric concentration of greenhouse gases remained relatively stable for thousands of years. It is extremely likely that human activities such as burning fossil fuels and raising greater number of livestock are the dominant cause of the recent and dramatic rise in greenhouse gases concentration. Globally, livestock production accounts for an estimated 14.5% of greenhouse gases emission related to human activities. Here I'm talking about the impacts of climate change on agriculture. Agriculture has always been sensitive to the effects of unpredictably fluctuating weather, but a fast changing climate is making it even more so. Warmer temperatures may enhance crop output in some areas. Climate change, on the other hand, is projected to have a detrimental influences on agriculture, lowest food supplies, and rising food costs. Many places already experiencing high level of poverty and food insecurity, such as sub-Saharan Africa and South Asia, are expected to have the biggest drop in food output. 7 to 9 higher amounts of carbon dioxide in the atmosphere are projected to diminish zinc, iron, and other key nutrients in crops. Here I'm talking about Texas corn crops affected by droughts. For most of the world's farmers, the effects of climate change, including worsened problem of droughts, flooding, cyclone, heat waves, and pests, are expected to reduce the amount of food they can grow. Impacts to agriculture can in turn lead to higher food prices. As a result of climate change, many regions that already suffer from high rates of hunger and food insecurity are predicted to experience the greatest decline in food production. In drought-stricken regions like Kenya, many cattle farmers have already lost their animals, their livelihoods, and their sources of food and income. Food prices in area meanwhile have skyrocketed.